Today we're going to learn how cross product works in geometry nodes. So let's see. So here I have a simple setup with three vectors. The blue vector, the yellow vector, and the red vector. And I can move all of them, moving, for example, this position. So now I'm moving the blue vector. I'm moving the position of this point that is connected with a line in this position and in the center of the wall. Also, what I can do is to move the red vector, and the same with the yellow vector. Okay, however, what I want is that the yellow vector is the result of a math operation between these two vectors. So here we are going to use a vector math. And we are going to select cross product to see how it works. So as you can see, a cross product is a vector math operation that needs two inputs, one vector and another vector. So let's connect this one here and this one here. And let's see how the yellow one looks like. Okay, so we have this vector. This is the cross product between these two vectors, these two positions. So how it works? As you can see, it's perpendicular between these two lines, these two vectors. Let's try to see if always is perpendicular. So I'm going to try to move the blue one, and let's see how the yellow one reacts. Now let's do the same with the red one. So as you can see, always the cross product is 90 degrees between every vector. So this angle is 90 degrees. And the same with this one. Always is 90 degrees. So the cross product between two vectors always is the perpendicular line between these two vectors. Now I'm going to use two empties to control these two positions. So I'm going to delete this and add two empties. And let's connect it here. So now basically I can control the position of the red one with this empty. And the same with the blue one. So we can see always that the yellow one is perpendicular to both vectors. I can rotate it that always we have this perfect 90 degrees angle. So the best way to think how this works is basically like a normal. So try to think like these two vectors create a surface, a face. And you know that every face has a perpendicular line that is called normal, right? So normal is the perpendicular line of a face. So we could say that the cross product between two vectors is like the normal between these two vectors. So we can use cross product to get the normal of two vectors and later apply it to something. For example, what we can do, what if I want to add here a face that always follow the direction of these two vectors? So to do this, let's try, for example, to add a grid. So you can see a better example of cross product. And let's add here, let's connect it. And what I want is to add transformation. Because what I want is to rotate this axis. So what I want now is perfect, is perpendicular. But I want that if I move this, the plane follow this line, the normal. So what we have to do is to add here a line Euler to vector. And in vector, usually we will connect the normal. But now we want this line, because this line is like the normal between these two vectors. So if we connect the cross product here, and really important, select Z, now we are using this as a normal to align this plane. So you can see that always this plane is going to be aligned with the normal between these two vectors. So always is aligned. Always, as you can see. I can delete this if you want to see better. That always is aligned to the normal. So it's perfectly in this axis, as you can see. Maybe with this vector, it helps you better to understand how it works. But remember, you don't need this line to see how it works. It's just for this tutorial to visualize the result of the cross product. By the way, if you want to control the length of cross product, what you can do is to add after cross product, normalize. Remember that normalize convert the length of a vector to one value. So now it doesn't matter if we move this, that always will be 1. And if you want to control the scale of this, then we can add here a scale. So we can say, instead of 1 meter, I want 3 meters. And now we are controlling better this line that represents the cross product. So I hope this helped you to understand how cross product works. And remember, we always need 2 vectors. And if we do the inversion, then this line will be the other direction. So if I connect this here and this here, you can see that's the opposite. But always, always, always is perpendicular to these vectors, to the imaginary face that we have. It's the normal of this face that is being created between these 2 vectors. I hope you learned something new, and if you like this video, give a like, subscribe, and you can download this project and many more on my Patreon. And see you in the next video.